Hello. So this lesson is about permutations, and this is 11.7b notes. So we're going to take first look at what a permutation is. So a permutation is an arrangement of items that occurs when no item is used more than once. And the order of arrangement makes a difference. So those are the two things that you'll know when it is a permutation. Now, for the next ones, we're supposed to determine if each scenario presents a permutation, and if it is not a permutation, then we're going to explain why not. So again, we're looking at no item is used more than once, and the order of arrangement makes a difference. Okay, so number one, an ice cream shop has two choices of cones, sugar and non-sugar, 4 choices of flavors, chocolate, vanilla, mint, and strawberry, and 3 choices of toppings, walnuts, sprinkles, and chocolate chips. Every order gets 1 cone, 1 kind of flavor, and 1 topping. How many possibilities are there? So if you think about this, we've seen similar examples, just like this one is, in 11.7a, which were not a permutation. Instead, it was the fundamental counting principle. And I mean, if we look at, so no item is supposed to be used more than once. Well, that is true in here. So we're only using 1 cone, 1 kind of flavor, and 1 topping. But does the order of arrangement make a difference? No, it does not. You can choose whichever one first. It does not matter which one you're going to choose first. So this is not a permutation. Instead, it is a fundamental counting principle. Okay, number 2. A state uses 5 symbols for their license plates. The first 3 are numbers, the last 2 are letters. How many possibilities are there? So, again, does it represent a permutation? No item is used more than once. Well, if we have 5 symbols for the license plates, the first 3 are numbers. The first 3 numbers can be the same one. It doesn't matter. It doesn't change. So this part here is not true for this one. So this is not a permutation. It's again the fundamental counting principle that we're going to be calculating with. Okay, number 3. A comedian has 6 jokes. How many ways can he order his routine? So we have 6 jokes. And when the comedian orders his routine, if you think about it, he takes 1 joke and then that 1 joke is used. Then he takes the next one and then that is used, and so on. So if we look at no item is used more than once, well, that is true. You only use the joke once. And the order of arrangement makes a difference. Yes, it does in his routine. It makes a difference. So this is a permutation. Number 4. There are 15 students in the film club. 4 officers must be chosen: a president, a vice president, a secretary, and treasurer. So again, if we look at the permutation, let me see if I can get this thing so that you can actually see the whole paper, so we can see the top as well. Maybe. Okay. So yeah, 15 students, and then we're going to choose 4 officers. Well, we can only use 1 student for each role. So we cannot use the same student for a president and a vice president. So this first one is true. The order of arrangement makes a difference. Yes, it does. So then when these are chosen, usually in these cases, you choose the president first, so then the ones who don't get that spot can run for, a vice president or a secretary or a treasurer. So yes, this is a permutation. Well, number 5. There are 15 students in the film club and they must select 4 people to send to conference. So very similar to what we had here, except now they must select 4 people to send to conference. Well, we're still, if it's 4 people, we can only use 1 student once. So this first one is true. But then the next one, the order of arrangement makes a difference. Well, for this one, it does not, because all 4 that are selected will get to go. So this is not a permutation. Okay, let's move on to the next page. Okay, here we go. Solve each problem. So we have 5 singers are performing. How many lineups are possible if each singer performs once? So we start with 5 singers. That is what we start with. So after we pick the first one, we only have 4 left. After we pick the first 2, we only have 3 left. And then we only have 2, and then we only have 1. So we are multiplying these again by each other. And when we multiply, we get 120. Now, number 7. In the example above, one of the singers insists upon being last. How many lineups are possible? So here we have the 4 singers. We have, or 5 singers. We have the same 5 singers again. But now, one of them insists on being last. So that one singer, there's only one option here. But what happens in the beginning here, if this one wants to be last, then we only have 4 options for the first one, because that one singer can't be included in this. Here, all the 5 singers are included in, because it didn't matter in what order they were performing. But for this one doesn't want to go until last, so we only have 4 that are trying to figure out the other spots. So that means that we only have 3 here, 2 and 1, and then the 1 here. So this is going to be 24. So notice the difference. We had 120 here, but when one wants to be in a certain spot, it goes down to 24. Next, you have 10 different books. How many ways can you rearrange them? So 10 books. First, so we start with the 10. We have 10 first. Then we put one of them as the first book. We choose one out of this 10. So that is gone. We have 9 left. Next, we have 8, 7, 6, 5, 4, 3, 2, and 1. And when you put this multiplication in a calculator, you get 3,628,800. Okay, so that gets a bit tricky. and a lot of numbers to put in the calculator. Well, we have what is called a factorial notation. This factorial notation looks like this. It will have the number, right now it's a variable n, and an exclamation mark. So what this means is we start whatever the number n is, and then we multiply 1 less and then 2 less until we get to 3, 2, and 1. So, for example, this one here, we could have done with the 10 factorial. And you can find it on your on the calculator here. I'll show you. So I'm gonna put the 10 in, and then I'm pressing this PRB. See, it has all those different ones. I'm gonna go to the exclamation, the factorial notation. Click enter, and now click enter, and there's the same answer that I got from multiplying all of them. So again, it's behind this here. There, and you need to use the arrow keys to go to the exclamation or the factorial notation. Okay. So what we're going to do now is we're going to, use that factorial notation to work these problems. So we have 7, and we're going to find that factorial notation, enter, minus 3, and again, enter, and now hit enter, and we get 5,034. So now look at the difference. So here we have the 7 factorial notation minus 3 factorial notation. This one, we're going to do 7 minus 3. Well, 7 minus 3 is the same as 4 factorial notation. So 4 and factorial notation, enter, and another enter. And we get 24. 4 times 3 times 2 times 1. Okay, so next we have, again, inside the parentheses, 12 divided by 4, and then the factorial notation. So 12 divided by 4 is 3, and we're taking the factorial notation from that. So notice that I'm doing what's inside the parentheses first. And of course, you can do it on your calculator. Put 12 divided by 4, parentheses closed, and then put the factorial notation equals, and you get 6. Same thing if you did 3 factorial notation, you get 6. So the same answer. It's just less typing since I know it's 12 divided by 4 is 3. But you can put it in. Just don't forget those parentheses. Okay, well, let's look at next one. So we have 9 factorial notation. 9 factorial notation divided by 6 factorial notation. And that is 504. Now, let's go on to the next one. So we had 104 factorial notation. 104 factorial notation divided by 102 factorial notation. See what happened. It says overflow error. I can't do this. So I'm going to show you a way that we can actually do it. We're going to take this one first and look at it. So the 9 factorial over 6 factorial, I can actually, instead of this, I can write it out like this, like we did here. So I can do 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 6 times 5 times 4 times 3 times 2 times 1. Well, now what we can start doing, remember, or yeah, when we have the same numbers on the top and the bottom, we can do 6 divided by 6, which is a 1. So this would end up being 1. 5 divided by 5 is 1. 4 divided by 4 is 1. 3 divided by 3 is 1. And 2 divided by 2 is 1. Well, 1 divided by 1 is 1. So all these are 1 times 1 times 1 times 1. What we have left here is 9 times 8 times 7. And now when we put that in a calculator, 9 times 8 times 7, we get what we got here, 504. So what happened here? We canceled out everything on the bottom. Well, we have a 1 on the bottom still. It doesn't, like, these are all 1s. It doesn't become a 0 because we can't divide by 0. So these are all 1s. So basically we have 9 times 8 times 7 over 1, which is 504 over 1, which is 504. So what happened here was this was a 6 factorial. So the only things that we have left are the ones that are not on the 6 factorial. So the next number from 6, 7, 8, and 9. So on this one here, what we can do is, instead of writing all this out, I mean, I don't want to write 104 numbers. We know that 104 factorial includes 102 factorial and all those, because 9 factorial includes 6 factorial. So the only ones that are going to be left from this are 104 and 103, right? Because the next number is 102, and those we can cancel out. So now we can do 104 not divided, multiplied by 103. And there's our answer, 10,712. Okay, well, let's try this next one. 29 factorial divided by 24 factorial. So that is what? 1425600. So there's a comma, 1, 2, 3, 1, 2, 3. So 14,250,600. So we could still do that. Or we could have done 29 times 28 times 27 times 26 times 25. But the calculator took that. Okay. Next, we're going to talk about duplicates. If we have duplicates, what happens is, so we have our factorial notation, and then we're going to divide by those duplicates. So n1 time factorial notation of n1, factorial notation of n2, and then all the way to factorial notation of n1. So let's look at an example. Number 10, how many ways can you rearrange the letters or numbers? So what do we have? We have the letter T, and that we have 1 time. We have the letter A, we've got 1, 2, and 3 letter A's. L, we have 2. H, we have 1. S, we have 2. And E, we have 2. Now, how many letters do we have altogether? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11 altogether. So we're going to do 11 factorial notation divided by, and now we're going to do a factorial notation of all of these. 1, 3, 2, 1, 2, and 2. And now, so that's a 1, that's a 1, this is a 1, and this is a 1. But now, remember when you're doing this, you have to, if you're putting all this in the calculator, and I recommend doing it, you need to put all this inside the parentheses, so that the calculator knows that you're dividing by all of these. So 11 factorial notation divided by parentheses. Well, 1 factorial notation of 1 is 1, so we don't have to put that in. We're going to do 3 factorial. You can put it in, but it doesn't really matter. Multiplied by 2 factorial notation. Well, 1 is again 1. And actually, the factorial notation of 2, that's 2 times 1, which is a 2. But we can do it 2 just to make sure. You only can do it with the 2 factorial notation. And then we're going to close the parentheses and do. So we get 831,600 different ways. So yeah, I could have done it. So 11 factorial notation divided by, again, 1 is 1, 3 factorial notation times 2 times 2 times 2. So I'm just doing times 2. Close the parentheses, and I get the same answer because the factorial notation of 2 is 2 times 1. Okay, so next we have the word Mississippi. So we're going to figure out what how many of each there are. So we have M, 1. I, 1, 2, 3, 4. So that's an I. This is a 1. Not to be mistaken for the other. S, we have 1, 2, 3, 4. And P, we have 2. And altogether we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 again. So factorial notation of 11 divided by factorial notation of 1, factorial notation of 4, factorial notation of 4, and factorial notation of 2. Okay, and again, don't forget to put these inside the parentheses if you're, doing it all at once. 11 factorial notation divided by parentheses. Again, 1 is a 1. That doesn't change anything. 4 times 4 times 2. Close, and we get 34,650. There are a lot of ways we can rearrange these letters and numbers. Or these letters. Let's look at the numbers. We have 1, 2, 3, 4, 5, 6, 7. So we have 7 altogether. We have 1, 5. So that's going to be a factorial notation of 1. 4, we have 2. And 6, 1, 2, 3, 4. So 7 factorial notation divided by, again, parentheses, 2 factorial notation times 4 factorial notation. Close, and we get 105. There we go. Number 11, 7 cars race. There are no ties. How many ways can the first 3 finish? So the first 3. We have 3 out of the 7 cars. So the first can't be any of those 7 cars, right? Then we take that who's first out. What am I writing? First, second, we take this driver out, or the car out, and we have 6 left. Third, we have both of these drivers out, so we only have 5 left. So, and that's it. It's only the first 3. We're not looking at the other places. So 7 times 6 times 5, that would be 210 times. Okay, next, permutations of n things taken r at a time. You might have seen when I did that, or when you're doing the factorial notation, that there is something that looks like this. And that's what we're going to be using now. What this means is we have n factorial, and then we have n things, and we're taking r at a time. And again, it's on here when I do this. There it is, the permutation. You just have to be careful how you're going to type it in. So a DJ has 13 records to choose from. Oops, 13 records. If he plays 7 of them, how many orderings are possible? So 13, permutation of n things. Here, n is 13. And he's taking 7 at a time, so r is 7. So the way we're going to write this is like this. And we can do it as a 13 minus 7 factorial notation. So the way we're going to put it in the calculator is we're going to do 13, then click this, and 7. There's our n, there's our r. Enter. And there's our answer. We don't need to do this. We can just put the 13, this permutation, and then 7. So we have 8, 6, 4, 8, 6, 4, 0. So 1, 2, 3, 1, 2, 3. 8,648,640. That's a lot of different orderings. Okay, next. You list your 20 favorite movies of all times. How many ways can you rank your top 3? So 20 favorite movies. In this case, our n is 20. And we're taking 3 away, or 3 at a time. So those are the top 3. So it looks like this. So we're going to do 20, that permutation, 3, and equals, and we get 6,840. Okay, that's it for this lesson. Let me know again if you have any questions. Bye.